My dear students of ninth standard, now we are discussing about Unit 13 chemical bonding. Already we have started and discussed up to 2-3 pages. Now we are going to further move in this chapter. Before that, we are going to discuss about some importance in the previous matter. Then already you learned about what is an atom. Atom is the smallest particle and which is normally atom exists as an independent entity in nature except noble gases. And group of atom is called molecule. The attractive force which hold the atom together is called bond. So we are learning about a chemical bonding. That bonding is nothing but the attractive force which holds the atom together is called a bond. Also, you learned about a definition of a chemical bond. That is the force of attraction between the atoms that binds them together as a unit is called a molecule. Also, we learned about octet rule. Octet rule is nothing but that is the tendency of atom to have 8 electrons in the valence shell. The phenomenon or the property that is called the tendency of an atom having 8 electrons. That attaining 8 electrons may be by losing or gaining electrons from the valence shell. And also we learned about why do atoms combine to attain the stability, the stable. How do atoms combine? Atoms combine by losing or gaining electrons. Why do certain atoms combine while others do not? Atoms of like the rare gases already in stable structure, so they will not going to lose or gain. The remaining atoms are going to gain the stable structure by donating or accepting electron. Now we are going to learn about this dot structure. When atoms combine to form compounds, their valence electrons involved in bonding. So already we learned what is called a valence electron. Valence electrons are nothing but the electrons present in the valence shell. The electrons present in the valence shell. So what is valence shell? Valence shell is the outermost shell of an atom. The outermost energy level, the outermost orbit of an atom. Then, therefore, it is helpful to have a method to depict the valence electron in the atom. This can be done using list dot symbol method. The list dot structure or electron dot symbol for an atom consists of the symbol of the element surrounded by dots representing the electrons of the valence shell of atom. The unpaired electrons in the valence shell is represented by a single dot, whereas the paired electrons are represented by pair of dots. So usually, to understand the list dot structure, first we are going to write the symbol of the element. The symbol of the atom of element is going to be written, and surrounded by the symbol of atom of element, we are going to depict the valence electron. Only valence electrons are going to be depicted around the symbol of the element, and in this case we used to put dots. To represent the electrons. Normally, the unpaired electrons in the valence shell is represented by single dot. Unpaired electrons are represented by single dot. Paired electrons are represented by two dots. It is called pair of dots. And symbols other than dots like crosses or circles may be used to differentiate the electron of the different atom in the molecule. Suppose the molecule is made up of different kinds of atom. That may be a heteroatomic molecule like a hydrogen chloride, water, and hydrogen and chlorine in water, hydrogen and oxygen. So when different kinds of atoms are combined to form molecule, we use to put the dots for one kind of atom. For another kind of atom, we use the crosses. We used to put crosses or circles to differentiate the electrons of the different atoms in the molecule. Then here some examples are given in table 13.3. Lewis dot structure. Element hydrogen. Hydrogen atomic number 1, which is the simplest element in the periodic table and having atomic number 1. Atomic number 1. So atomic number means the number of electron or the number of protons present in the nucleus. So only one electron, that is going to be in the first shell, the K shell. So valence electron is 1. So only one electron, that is unpaired electron, that is going to be placed by the side of the symbol of hydrogen, H. That is the symbol of hydrogen. Then helium. Helium, that is in the atomic number 2 in the periodic table, second place, and the 2 electrons, and it is going to be in the first shell. K shell is completely filled, 2 valence electron. It is a pair of electrons, so 2 dots should be given. Beryllium, atomic number 4. Atomic number 4. So first shell, K shell is completely filled. Then the remaining 2 electrons are placed in the second shell, L shell. So the outermost shell electrons are valence electron. 2 electrons in the valence shell. So these 2 electrons are going to be depicted by the side of or surrounded by the beryllium symbol B. Carbon, atomic number 6. Atomic number 6. The first 2 electrons are placed in the first shell, K shell. The remaining 4 electrons, valence shell. So 4 electrons in the outermost shell, that is in the valence shell. These 4 electrons are placed by keeping dots surrounded the carbon symbol, symbol C. The nitrogen, atomic number 7. Atomic number 7. So it can be written 7 electrons are there, 2 electrons in the first shell, because the first shell can have maximum only 2 electrons. So K shell 2 electron, the remaining 5 electrons in the 5 shell. So 5 electrons are the valence electron, which is in the outermost shell of nitrogen atom. These 5 electrons are placed surrounded by the nitrogen symbol N, and 2 dots are placed, that is a paired electron, remaining are unpaired electron. Then oxygen, atomic number 8. Atomic number 8, 8 electrons. First shell is completely filled, 2 electrons. The remaining 6 electrons in the next shell, L shell. 6 electrons are valence electron. 6 electrons are valence electrons in the oxygen atom. And these 6 electrons are placed surrounded by the oxygen symbol O. And say in the more to know, note that dots are placed one to each side of the letter symbol until all 4 sides are occupied. Then the dots are written 2 to a side until all valence electrons are accounted for. The exact placement of single dot is immaterial. So the single dot can be placed at anywhere, but the placing the valence electron surrounded by the symbol of the atom is immaterial. We can place around the symbol of the element. Then next see types of chemical bond. So all the elements have different valence shell electronic configuration, because they are having different atomic number, so they are going to have different valence electron. So the way in which they combine to form compounds also differ. Hence they are combined to form compounds also differ. Hence there are different types of chemical bonding possible between atoms which make the molecule. Depending on the type of bond, they show different characteristics or properties. Such type of bonding that are considered to exist in a molecule are categorized as shown in figure 13.5. Among these, let us learn about the ionic bond, covalent bond and coordinate bond in this chapter, and other types bond in your higher classes. So, depends upon the combining capacity of an atom of element. What is called combining capacity? That is called valency. Valency is combining capacity. That combining capacity is completely based on the number of electrons present in the valence shell. So the number of electrons are not same for all the atoms of element, because all the atoms of elements are not having same atomic number. Atomic numbers are differ. So when atomic numbers are differ, the valence electrons also differ. Electronic configuration is differ. So their bonding ability, the formation of molecule also differ. So based on that, we are going to study about three type of bonding in this chapter: ionic bond, covalent bond, and coordinate bond. First, 13.3.1, ionic or electrovalent bond. So this bond is also called ionic bond, electrovalent bond, ionic bond, electrovalent bond. So see, an ionic bond is a chemical bond formed by the electrostatic force of attraction between positive and negative ion. Sometimes we will be asked what is called ionic bond. This ionic bond is formed between opposite charge ions, between positively charged ion and negatively charged ion. Positively charged ion is called cation, negatively charged ion is called anion. So between these two different types of ions, there is a force of attraction that is called electrostatic force of attraction. So because of this existing electrostatic force of attraction, these different kinds of ions are combined together to form a molecule, to form a compound. So that's why it is called ionic bond. The bond is formed between two atoms when one or more electrons are transferred from the valence shell of one atom to the valence shell of other atom. The atom that loses electron will form a cation, positively charged ion, and the atom that gains electron will form an anion, negative ion. These opposite charged ions come closer to each other due to the electrostatic force of attraction and thus form an ionic bond. The bond is between the ion, it is called ionic bond, and attractive forces being electrostatic, the bond is also called electrostatic bond. Since the valence concept has been explained in terms of electron, it is also called electrovalent bond. And see, first you have to understand that what is ionic bond. That is a bond formed between the opposite charge ion. The bond formed because of the electrostatic force of attraction between positively charged ion and negatively charged ion. And see how this positively charged ion and negatively charged ion, that is a cation and anions, are formed. See, the positively charged ions are normally formed when the atom loses electron. When an atom loses one or two electrons from the outermost shell, from the valence shell, that atom becomes a positively charged ion. Similarly, when an atom going to gain electron, that atom becomes negatively charged ion. So positively charged ion is cation, negatively charged ion is anion. Positively charged ion is formed by the loss of electron. Negatively charged ion is formed by the way of gain of electron. So opposite charged ions are first formed, and these opposite charged ions are come closer to one another because of electrostatic force of attraction, because of the attraction of opposite charged ions. And the bond is developed, and due to this bond developed because of the ions, it is called ionic bond. The bond between opposite charge ions, so it is called ionic bond. Also this is called electrostatic bond. Why it is called electrostatic bond? The force is developed. There is a force, the attractive force. That force is called electrostatic force. Electrostatic force. So the electrostatic force is developed between this opposite charge ion. So it is also called electrostatic bond. And also this electrostatic force or ionic bond is developed from the valence electron. By that valence electrons, that is the electron in the outermost shell, that going to be lost or gained. So valence shell is, or valence electrons are important for the formation of this bond. So it is also called electrovalent bond. So ionic bond, electrostatic bond, and electrovalent bond. Now we are going to see one example, that is a formation of ionic bond, how the ionic bond is formed. And we are going to consider two atoms. Here simply uh, alphabets are given A and B. We have to consider one atom is A, another atom is B. Let atom A has one electron excess and the atom B has one electron lesser than the stable octet electronic configuration. So it is given, see, A has one electron excess than the octet structure. B has one electron lesser than the octet structure. First, you already learned what is called octet structure. That is the tendency of an atom having 8 electron in the outermost shell. 8 electron. Octa means 8. The atoms which are having 8 electron, their outermost shell are already stable in structure. For example, noble gases. So here A is 1 electron, that is atom A has 1 electron excess compared to octet structure. B has 1 electron lesser than the octet structure. So what happens? See, automatically atom A transfer that 1 electron from their outermost shell to atom B. So by the way of transferring 1 electron from atom A to B, both the atoms going to acquire stable octet electronic configuration. As a result of this electron transfer, atom A become positive charge ion and atom B become negative charge ion. Positive charge ion is called a cation, negative charge ion is called anion. And these opposite charge ions are held together. So when these opposite charges develop, electrostatic force of attraction is developed, and these ions are come closer to one another and going to combine to form a molecule. And this kind of bonding combination is called ionic bond or electrovalent bond or electrostatic bond. In general, ionic bond is formed between metal and non-metal. So normally metals are ready to donate electrons. Metals are electropositive in nature. Non-metals are electronegative in nature. So the compound containing ionic bond are called ionic compounds, like elements in the group 1 and 2. The first group, when you take the periodic table, that last lesson we have learned, the group 1, what are called group, the elements present in the vertical columns. First group are the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are in the first group. And the second group, alkaline earth metals, that is beryllium, magnesium, calcium, strontium, barium, radium, they are called as alkaline earth metals. So these alkali and alkaline earth metals form ionic compounds because these elements, their atoms are ready to donate, ready to lose electron from their outermost shell. So they are going to be electropositive in nature, also called electropositivity. And more to know, the number of electrons that an atom of an element loses or gains to form electrovalent bond is called electrovalency. So, how many electrons are take part in the bonding? That means of transfer of electron. Transfer means loss of electron or gain of electron. That is called the electrovalency. Electrovalency. Now we are going to see one example, that illustration, formation of ionic bonding in sodium chloride. Sodium chloride formula NaCl. The atomic number of sodium is 11. That means number of proton 11, number of electron 11. So configuration can be written 2, 8, 1. 2 in the first shell, 8 in the next shell, then M shell can have 1 electron. So it has 1 electron excess compared to the nearest noble gas, that is neon. The atomic number of neon is 10. So its configuration is 2, 8. So it has 1 electron excess compared to the neon. So automatically the nature of the tendency of sodium is losing 1 electron from the outermost shell. By the way of losing 1 electron, sodium atom become sodium positively charged ion, cation. Also we have to consider the atomic number of chlorine is 17. So 17 proton and 17 electron. So configuration can be written K shell 2 electron, L shell 8 electron, M shell 7 electron. So it has 1 electron less compared to the octet structure or compared to the nearest noble gas of argon. So argon atomic number 18. So configuration 2, 8, 8. So normally the chlorine has the tendency to gain one electron from their combining atom, for example from sodium atom, and going to satisfy the role of fate. So it has the tendency of gaining. So chlorine is electronegative in nature, electronegative character. Electronegative character means the tendency of gaining electron from the combining atom. So here, so what happens, see that see the picture figure 13.6. See sodium atom 2, 8, 1. That is 2 in the K shell, then 8 in the L, then M shell 1. And chlorine 287, K shell 2 electron, and L shell 8 electron, M shell 7 electron. Then during this chemical bonding, the sodium atom, which has 1 electron more than the active structure, is going to be donated, transferred to chlorine atom. So sodium donate 1 electron to the chlorine atom. By the way of transferring 1 electron, sodium going to attain stable octet structure of 2, 8. By the way of gaining 1 electron from sodium atom, chlorine also going to attain octet structure of 2, 8, 8. 2, 8, 8. And here sodium is going to be positively charged cation, chlorine is going to be negatively charged anion. So there is a bond, there is a attractive force, it is called electrostatic force. Because of the electrostatic force of attraction, that the sodium and the chlorine combine to form a stable sodium chloride molecule. Sodium chloride molecule. And also see, when you take the next illustration, formation of ionic bond in a magnesium chloride, magnesium atomic number 12. So 12 means a configuration 2, 8, 2. It has a 2 electron excess compared to the octet structure, nearest to noble gas of neon. So magnesium has the tendency to donate, lose electron. So magnesium donate 2 electron to the combining atom, and by the way of it is going to be a positively charged magnesium cation Mg2 plus. And the formula of magnesium chloride is CO2. So here 2 chlorine atoms are going to combine to magnesium atom. So each chlorine atom going to gain 1 electron from the magnesium atom, and the magnesium chloride molecule is formed. So the nature of bonding between the atoms of a molecule is primary factor. So see the picture 13.7, magnesium configuration 2, 8, 2, chlorine 2, 8, 7. Chlorine 2 atoms of chlorine combine to 1 atom of magnesium, and the 2 electrons, valence electrons of magnesium, each one donated to each chlorine atom. So both the chlorine atoms going to attain stable octet structure. So magnesium chloride molecule is formed. Magnesium chloride molecule is formed. And see, next we are going to study about the characteristics of ionic bond. The nature of bonding between the atoms of a molecule is primary factor that determine the properties of compounds. By this way, the ionic compounds, the atoms are held together by strong electrostatic force of attraction. So there is a strong force is attained between opposite charge cation and anion. Because of this reason, the nature, the characters, the properties of these ionic compounds are more or less entirely different. Entirely different because strong force is developed. So they are going to be solid, rigid, and electrically they are going to be will not easily conduct electricity at normal condition. So there are important points that we are going to learn. First is the physical state. These compounds are formed because of strong electrostatic force of attraction between opposite cation and anion. So they are going to be solid at room temperature. So the physical state is crystalline solid at room temperature. That point you have to note down. Then electrical conductivity. These compounds and atoms are held together because of strong force of attraction. So they will not easily conduct electricity in normal solid state. But when they are in the molten state, aqueous solution state, they may conduct electricity. And melting point, boiling points are high because it is not easy to break the electrostatic force of attraction. So it needs extra energy, extra support to break the bond. So the melting and boiling points are high. And solubility. Ionic compounds are normally soluble in polar solvents, that is water. Water is the solvent for ionic compounds. But non-polar solvents like benzene, carbon tetrachloride ether, and these solvents are not useful for ionic compounds. Then their density and hardness, brittleness. Ionic compounds have high density because of a strong force of attraction. So the electrostatic force of attraction is very, very important because that plays very important role to uh, the characteristics for the characteristics of these ionic compounds. Because of the strong electrostatic, they are going to be solid and they will not easily conduct electricity in solid state, and their melting point is high, boiling point is high, and soluble only in polar solvents, and their density, hardness, everything is going to be more and greater. So ionic compounds have high density and they are going to be hard because of strong electrostatic force between the ions, and they are highly brittle. And the reaction, ionic compounds undergo ionic reaction, and these reactions are rapid. The reactions are very fastly take place, and the instantaneous immediately it's going to be take place because the ions are very fast to react to give a new compound. Then so my students, you have to go through up to this ionic compound. What is ionic compound? You have to first know that ionic compounds are nothing but the compound formed because of a positive charge and negative charge ion, and also this is called electrostatic bond because of the electrostatic force, and also called electrovalent because of the valence electron. And we learned about how ionic bond is formed by the way of losing or gaining electron. Also we learned about the formation of sodium chloride molecule and magnesium chloride molecule, also the properties of or characteristics of ionic compound. So learn up to this, and this lesson will be for the next terminal examination. So you have to prepare and get ready. And the first week of February you will have terminal examination, second terminal examination. For that this lesson is going to be given. So prepare well and don't waste the time. Thank you. God bless you.